Okay, let's just talk about data packets and packet switching in data transmission here. So basically, when we're talking about the part on data transmission, we are talking about data being transferred from point A to point B. So we have data that is on point A, we want it to get to point B, right? So in doing that now, we might use what is called packet switching. So let's take, for instance, that we have A and B separated with some routers, right? A and B separated with some routers. We have A on one side, A here, then A has got a router here, another router here that are in the midst, right? So this is router, this is router, this is router, this again is a router. Let's say another router here, another router here, and we have B now, right? What's going to be happening now on packet switching is that A will type a message. Let's say that the message is comms is fun. Comms is fun, like this. That's the message that A wants to send to B. What's going to be happening first is that with packet switching, this message is going to be split into different packets. So we might have comms in its own packet, is in its own packet, fun in its own packet. So that the information is going to be transmitted now in separate slots like this. This is going to be packet number 1, packet number 2, packet number 3, right? And each packet is going to be coming through now with a packet header. Each packet is supposed to be knowing exactly where it's going. So we're going to be adding something here, which is going to be the destination IP address, source and destination IP address. The source, where it's coming from, the destination, where it's going. Then we need to be knowing again that which packet number is this. It may be packet number 1 of 3. This is packet number 2 of 3. This is packet number 3 of 3. Again, it's going to be coming through again with each packet is going to be coming through with the source and destination IP address and the packet number. Source and destination IP address and the packet number in here. So we call this now the packet header. It contains the source and source and destination IP address, the packet number, and even the packet size. Right? Then this, we call it the payload. So the payload now consists of the data that is being transmitted. This is the payload, this is the payload, the actual data that is being transmitted. So we have the packet header with the source and destination IP address, the packet number, and the size. Then we have the payload that's going to be consisting of the data that is being transmitted. Then, of course, we're going to be having the error detection mechanism found in the packet trailer. So those are the three things that make up a packet. We have the packet header, we have the packet payload, we have the packet trailer as well, right? So check this out. We're going to be having now, each packet is going to be choosing any route that is free from this point onwards. So packet 1 of 3 might take this route. It's packet 1 of 3. Packet 2 of 3 might take this route. Packet 3 of 3 might take this route. So each packet is going to be taking any route that is going to be free at any point in time, which leaves the job now to the last router to combine or to reassemble all these packets, because they might arrive at different times. Maybe 2 of 3 is the one that's going to be arriving first, followed by 3 of 3, followed then by 1 of 3. You get the point? So there is need now to rearrange them now to have 1 of 3, followed by 2 of 3, then 3 of 3. You get the point? So the packets are split here. The data is split into packets here, and they are reassembled now when they are reassembled, when they are received now by the receiver. They are reassembled now to form the original message that was sent. If any packet does not get to the receiver, an automatic repeat request is going to be sent so that A will just resend the packet that was not received by B, so that when reassembling, all the packets would have been received. And I hope that makes sense. So let's take this one more time. So we're saying that before transmission, all files can be broken into smaller chunks called data packets. So each packet is very small, usually just 64 kilobytes in size. So data packets will avoid busy or broken routes, so that they always take the route that is deemed to be the fastest at any particular point in time, right? So we're saying all of this means that the data packets will arrive out of sequence and will need to be put back into order by the receiving computer, like I've mentioned before. Check this out. So if the structure now of a data packet, a packet consists of 3 sections. We have number 1, we have the packet header, which consists of the sending IP address, receiving IP address, the packet sequence number, then we have the packet size as well. Yeah? Then the payload is the number 2 part. This is number 1. Number 2 is going to be the payload, which contains the actual data that is being sent. Then we have the packet trailer, which consists of the mechanism to identify the end of the packet, and also an error checking method. You get the point? And the last thing that you're going to be having now is that we can actually define packet switching as: packet switching is the process of transmitting data by splitting it into series of small data packets, right? A data packet will encounter several nodes, which are routers here, as it makes its journey from point A to point B. Check this part. Each node is a router, right? The router will process the data packet using the information found in the header section. So this destination IP address that is in the IP address is going to be telling us exactly where the packet is supposed to be going to. Yeah. So a router will independently send each packet onto the next leg of its journey using the most appropriate route at the exact moment in time. So if we have this route being busy, so this route, I mean to say, we'll cancel this route, and we'll send the packet to go via this route instead. It's basically what we're just trying to say. Each router knows exactly where to pass the packet to next, because of the part that each packet has got a destination IP address, and the router knows as well where the next packet, which route is actually free at any point in time. That's basically what we have as far as packet switching is concerned. Go through the video. I hope you're writing some summary notes, and you took again all these notes that are on the PDF. And if you have any questions, just touch base with me so that we may actually clarify some areas. Thanks.